good to see so many people here. I see people like standing in the back. If you want to like come closer, feel free. I think there's some space here. I hope that's okay. And huge shout out to Fonzie for having me here. My name is YK. Actually, I was standing here just earlier, and someone came up to me and they were like, "Oh, are you on YouTube?" I am on YouTube. If you recognize my voice or face, it could be from YouTube. It could be from past events because I've spoken at different events in San Francisco as well as other places. So who here is a software engineer? Software engineer. Nice. Who here is a recruiter? Everyone recruiter. Who here is a product manager? Field designer? Marketer? Founders? Nice, founders. Cool. Always good to get a sense of what the audience looks like, and we have 10 minutes here, right? We're good. Okay. I'm not gonna go over too much, but as you can see, this talk is called the Spectrum of Agentic Coding. As I said earlier, my name is YK, and I work at Daft. And just to give you a little bit of context here, I've been practicing the art and science of agentic coding for about 2.5 years now, and that's actually a long time in this domain of agentic coding. And that's just because I built one of the first agentic coding tools out there. It's called Kaguya. I built it as a ChatGPT plugin that gave ChatGPT access to your local drive, like your files. It was able to edit files and it was able to run commands. Nowadays, it's a pretty common idea, but back then it was a pretty novel idea. But obviously now we have tools like Cloud Code and Codex that do these things for you. And throughout all of that process, I've realized that vibe coding and traditional software engineering are not opposites; they are more complementary. And the way I visualize this is like this. I hope you can see this. The idea is, if you look at vibe coding, it's really fast, but not necessarily high quality. You can increase quality, and naturally the speed goes down, but you get to sort of these different levels of agentic coding. That's what I'm gonna dive into in this talk for about 8-9 more minutes. And I built I made a little cover image for this too. If you get the joke, you get the joke. So the first level is vibe coding, where you just let AI go wild, pretty much. You forget that the code even exists. You might say, oh, got error logs, just throw them at the AI. And version control, what's that? I might be a little bit too harsh here, but that's kind of the idea. And it's totally fine for one-off projects and experiments and stuff like that, right? But I wouldn't expect it to be maintainable in the long term. And one level above that is what I would consider as agentic coding with discipline. And on this level, you might have stuff like version control. You might start to understand not necessarily what code does on a line-by-line basis, but you might start to know what each file does and how they're structured, how they're related to each other. You might hopefully start to have some basic security precautions. And then you probably do a bit more thorough testing to make sure it actually works. Level 3 is what I would consider as agentic software engineering. We don't have to use these exact terms, but these terms feel right to me at this moment. In this level, you might write tests, or you might have AI write tests that you actually verify to make sure they're testing the right things. You might start to introduce traditional software engineering practices like pre-commit hooks for quick checks and CI jobs for continual testing. They could be like nightly jobs or something that you run for every push on your main branch. And you might start to have slightly deeper level of understanding of your code, not just file level, but also what each function does and what each class does as well. And hopefully you'll start to have additional quality control measures on top of those too. So these might be things like more careful manual testing, end-to-end tests, and you might start to have like PR review bots that review each PR automatically. And you might also have regression checks. And in my opinion, at the highest level, I would call it as high quality software engineering. And at this level, the idea is the quality should be indistinguishable from, let's say, handwritten code from, staff engineer, and still AI assisted. And with this, you will hopefully have, line by line understanding. You understand every single line of code that's generated. You might start to ask more self-reflection type questions. So these are questions like, okay, you generated this code, but are you sure about this? Or what about trade-offs? What about different approaches? I found that these types of self-reflection questions work really well. You might start to have interactive AI code reviews. I might need to have someone hold the mic for me for this part because I have a little demo here. So what I want to do is kind of show you what the interactive AI code review looks like. I have this merge PR. This is just a screenshot, but I'll just pretend that this is like an open PR. So I would say something like, okay, I want to review this PR, but there are a lot of files here. Cool, it's working. We have more than 200 files here. Can you walk me through it so that I know how they are structured, and can you walk me through them in the order where it makes sense the most to review them? And for the first file of those, can you walk me through it line by line? So I'll just do that. And then while this runs in the background, thank you so much for that. Sorry, what was your name again?
Mackenzie.
Yeah, shout out to Mackenzie. So in addition to those things, hopefully you start to have advanced research methods. So this is for things like architecture discussions and deciding what technology to use, what cloud, what language, what framework. And for this is essentially like Google replacement. Instead of doing manual 100 Google searches, you might use things like deep research or AI with search capabilities. And hopefully you start to have AI-powered quality control as well. What I mean by this is stuff like if you're creating, let's say, a CLI, instead of doing these manual tests and unit tests, you could also have your AI, test your CLI through things like tmux. If you're working on web apps, you might test them through AI, with web browser capabilities. And hopefully you start to have accelerated learning. What I mean by this is instead of just having AI generate code without understanding it, you use it to learn faster. So you might ask questions about generated code and generated commands and stuff like that, so that you learn, not just generate. And to summarize what I've talked about, I've created this table here. At the top, you have vibe coding where the quality is low, speed is really fast, testing, maybe bare minimum, code review might be none. And then at the bottom, you get high quality software engineering where the quality is obviously much higher, speed is decent, testing is rock solid, and code review is interactive. Now, I think the important thing to keep in mind when it comes to this kind of thing is to master all 4 levels, but be flexible about which one to use exactly. So sometimes vibe coding is totally fine, for things like quick prototypes, one-up scripts, and experiments. But sometimes you need high quality, so you might want to slow down for things like large-scale systems and mission-critical software, Mako software, and stuff like that. And I find kind of discourse around it really interesting because people say, sloppy is a huge problem, and it is a huge problem. But to me, a large part of it is not an AI problem. It's more of a human problem and how to use it. And I think kind of the general consensus sometimes is that if you generate more tokens, if you use more AI, you get more garbage. But that's not necessarily true. If you use more of the tools that I discussed here, then you should be able to create more quality, not just quantity, through spending more tokens, essentially. I'll just sort of leave this talk with this meme here. I'll let you, check it here. And going back to the demo here, you can see that I think he used the GitHub CLI to check these things. And this is just one prompt to get started with. But in reality, what I would do is, really go through them one by one. I would say, okay, what's in get ignore, and why do we have this thing in get ignore, and why do we have these things in comparison report, and so on. So that's the quick demo of an interactive AI code review. And that's pretty much it for this talk. If you want to find more, AI coding tips, but code tips in particular, that's on the left. It's almost at 2,000 stars on that GitHub repo. In the center, if you're an agent builder that needs access to like private data, a large amount of data, enterprise data, stuff like that, we are building a product for that. And feel free to find me on LinkedIn as well. Thank you so much.
Hold on one second. Does anybody have any questions? We can give 2-3 minutes for quick questions if anybody has anything and wants to shout it out. Stand up real quick. We don't have another microphone. Do you mind if they ask you a couple minutes of quick questions?
It's actually a comment on it. First of all, bravo, awesome, excellent. These are the 4 levels. I want to propose for you what I would call a level 5 tip. Okay. And that's where you use AI to sort of go over your entire code base to help improve your process. Great example. I was recently at a company where we had like 6 different repos that all worked together. And I realized we needed to make an agents.md, which would enforce coding standards. And so what I did is I had Claude create a PowerShell script that would process every single PR comment from our CTO that was always like enforcing all those rules for the last year in every repo, and then process that into the list of the patterns that you wanted enforced, and we created agents.md files, and now our agents behave the way the CTO wants. So I think that, does that fit? Have you never done anything like that? Like, I don't know if anyone else does stuff like that.
I have done like stuff like that, maybe not on that scale, but I really like that. I would suggest calling it like industrialized software engineering, maybe level 5.
Industrialized, yeah.
Time for one more. Yeah, go ahead.
Yeah, so how do you actually understand code at scale? Because you can ask like, what has...
Yeah, I think you could like, ask about architecture, like how it's architected and stuff like that, but my personal experience, it could be different for like, again, different purposes and different perspectives, but my personal experience has been that kind of by repeating that process of like understanding small pieces, then, over time you get to understanding a little bit better.
Okay, thanks. Yep. All right. Anybody else? One more final? We good?
What's your email address for LinkedIn connection?
It's yksu@csdojo.io. Yeah.
Ready to get that? And say it out louder again?
Sure. It's yksu@csdojo.io. Thanks a lot.
All right, everybody. Please, round of applause for YK. Great stuff. We'll get the next person up.
Hey, everybody. My name's Scott Clark, currently co-founder and CEO of Distributional, but I've been building AI companies for 10 plus years. So I'm going to talk a little about my journey, lessons learned, major mistakes I've made, and kind of what we've built now. But my first startup was all about AI optimization. So this was based off of my PhD research in Bayesian optimization. We helped firms like Netflix and OpenAI back when they were just building Dodo bots. And trillions of dollars worth of hedge funds do hyperparameter optimization and neural architecture search. So back when people would actually train and build their own models. I ended up selling that company to Intel in 2020, where I was VP of AI and HPC for the supercomputing group. So somewhat similar. We were trying to help government supercomputers run better physics models. And the early days of LLMs on, again, these massive, like what used to be large 100 megawatt data centers, that are now dwarfed by what people have today. But after about doing 10 years of AI optimization, I came to this realization that I think I was solving the wrong problem. And basically, I think that what's really holding back value in AI isn't performance, it's confidence. People don't stay up at night hoping they can overfit an eval by another 0.5%. When we would work with some of these great firms and help them optimize whatever objective function they threw at us, they would say, yeah, you made this number go up. My loss went down, my my cross-validation accuracy went up, whatever it may be. But it introduced this other weird problem. And so I founded Distributional in order to try to help solve this confidence problem. And I started out thinking I was building a testing company because I thought, well, how do you get confidence with software? You do it through testing. And as these Gen AI models were getting more prevalent, I thought, you know what? The traditional testing methods aren't going to work. These models are way more chaotic, they are way more non-stationary, and they are becoming inherently complex. So we need a better statistical approach to testing. And this was the first two of many, many mistakes I made in my second company. First off, nobody likes testing. And it turns out, if you write big, complicated statistical tests for them that they can't understand, they like it even less. And it's not very actionable to say, like, oh, the KS divergence of this one model is slightly different than the other. This is not actionable. The second part of this that I got wrong was I thought everybody was going to be afraid of AI. Because in my first wave of my company, doing hyperparameter optimization, people would be like, oh, random forests? Like, it's got random in the name. Does it have bias? Can I trust this? And no one wanted to deploy anything. Turns out that's not true for Gen AI. Everybody's just YOLOing agents out there. We've kind of collectively said sometimes it's going to hallucinate, but you don't show up on the front page in the New York Times anymore because your chatbot ordered 600 chicken nuggets. That's just the cost of doing business. So, nobody wants testing. This took me a while to figure out, but I shifted the company from testing into analytics. And so the idea is, instead of trying to catch things pre-production, what if we had better understanding of what things were actually happening in production? And the joy of this is if you do really good analytics and you can get a better idea of the patterns and the signals of what's happening and be able to extract that, you can build better evals, better reward functions, and things like that, which lets you do better optimization. So my true love is still optimization. This is a way to do what used to be called objective function solicitation, but it's really about reward function finding and eval finding and finding the patterns and signals that can help you build better software. But what really is analytics? Like, isn't this just observability? There's a million companies out there. I feel like half the YC batch, this last batch, was like, hey, look, you can see your traces now. The difference between analytics and observability is, I would say, it's part of a larger ecosystem. So yes, you still need monitoring and alerting. Being able to understand what's happening in your system, being able to catch known issues is incredibly valuable. But analytics is that next layer. It's trading off timeliness for richness. So instead of telling you very quickly that something you know about has gone wrong, the latency's way up, the eval's tanked, whatever it may be, it's about digging through that data to find what you might not know yet. So think about it like user analytics for a traditional web application. The user has it in a cohort, goes through a journey and a funnel. We're treating it the same way with agents, but instead of the user being the atomic unit, it's an agent that's traversing some directed graph of tools, etc. And the problem is, if you only look at monitoring, you end up missing a lot of things. It, again, can be really valuable for catching what you already know, but if you don't know what to ask, it's gonna slip through the cracks. And it can cause you potentially to overfit towards these known knowns as well too. Because if you have a single eval that you're trying to drive up, you might end up having a lot of issues. By coupling these things together, you can get a more powerful combination. You can be able to find these unknowns and be able to put that through your entire software development lifecycle, of which is the simplest, most basic example, where by observing things and catching them, you can make them better and then repeat. And this is this analytics-driven software development or agent development that this company is now morphed into. And fundamentally, I think about this as kind of this Maslow's hierarchy of observability. At the very lowest level, you need logging. You need to be able to just see what your system is actually doing, then monitoring, again, catching things, and analytics finally at the end. And you get different values for these. And for better or worse, analytics is at the top, so it's the last thing that you need, which means it's a terrible startup idea again. But fundamentally, I do believe this is obvious and inevitable that this is how people are going to be building agents over time. You need to be able to debug your code as you're building. You need to be able to catch behaviors you care about, but then you also need to be able to find behaviors that you might not be able to think about. Because at the end of the day, as these things become more and more chaotic and have more agency themselves, and as your users abuse your systems, there's so many different ways for these systems to break. And being able to catch that without being able to anticipate it is incredibly valuable. So what does this actually do? I'm going to show you a super simple example. This is one of the dog food apps that we've developed in-house. Think of it like a Yelp or a Google Maps kind of like agent where you ask it for something to do and it gives you an itinerary. So simple agent, but like there's some tool calls under here. We're hitting Google Maps, we're visiting websites, we're looking at Instagram, things like that. So if you're using this thousands or hundreds of thousands of times, it's going to throw out a bunch of logs. Hopefully these are like OpenTelemetry traces and you have like well-formatted logging and things like that. But again, the goal of analytics is to take those logs and be able to pull out individual patterns, do topic analysis, clustering, look at how individual patterns influence each other, find interesting correlations that might usually exist, but sometimes are anti-correlated, and pull those into more digestible insights. So fundamentally what the system is doing is it's looking through all of these logs, pulling the needles out of the haystack, and then presenting them to you in, here's some interesting behavior I found. It affected 1% of your users. Here's a couple examples, and here's how you could fix it. Everything from like copy and paste this into Claude Code to maybe architect a caching system or something like that. And again, fundamentally, this is just about that simple software development lifecycle I talked about before. You deploy a system, and this can be any agent on any framework, hitting any LLM. You want to be able to observe it. And I won't go into detail here, but I'll be here after the talk about how you can build up interesting behavioral embedding vectors and do unsupervised learning to pull out clusters and actually find these insights. But fundamentally, it's about optimization. You find these unknown unknowns, and then you pipe that back into your prompts. You can pipe these needles from the haystack into fine-tuning or reinforcement learning. But ultimately, you want this flywheel to spin as fast as possible and learn from what's happening online instead of only looking at whatever you came up with ahead of time to measure something. So that's analytics for agents and how we can help drive the software development lifecycle. The product itself is free, open distribution. It deploys on-premise. We're a very kind of enterprise-shaped software package. But you can pip install DBNL right now, spin up a sandbox on your laptop or a Kubernetes cluster within your VPC, and be off to the races. And we hope that analytics ends up being the driving force that gives people more confidence in their agents, but ultimately allows them to adapt and evolve them over time. Because you YOLO something out once, but you want to perpetually improve it to actually make it be valuable over time. And that's me. Great question. So for those in the back, do you need constant human feedback to score the topics? Just jumping back here, the whole goal of this is to like tab complete analytics. So we're going to present these insights to you. We're going to say, hey, like we found this weird pattern. And then it is up to the user, this bottom part here, the analytics workflow, to say like, I do care about this. We provide some investigation and exploration tools so you can like triage what was actually pulled up. But ultimately, you're either going to track the issue to make sure it doesn't happen again, write an eval so that we have a new signal in our behavioral vector to be able to find similar issues again, or you're going to say, I don't care about this. But over time, it like adapts to that yes/no that the human puts in. All right, I'll be here after. Thank you, everyone.
How's everybody? We got the TV working. How's the pizza? Good. Thanks, Fonzie, for hosting in House of AI. Awesome event. So yeah, my name is Wasim. I'm from Tesla Energy, so the energy side of the business, on a team called Commercial UIs. And what we do is we own a bunch of web UIs, both internal and external, for working with the energy devices that we have. The energy business, if you're not familiar, we own 3 verticals. So we have the power walls in-house, solar panels, and then supercharging network, and the mega packs for industrial. and we are hiring. So if you want to scan this, I will not get mad if you actually go and try to apply as I give the talk. So, okay, so my talk is going to be essentially about a design exploration or like a UX exploration for letting LLMs diagnose like an engineer, and specifically working with time series data. So think IoT or network events, things like that. The idea came from essentially when something goes wrong as an engineer, as a network engineer, or as a service engineer, we don't really stare at CSVs or like actual raw values. What we do is we use tools, we graph things, we create graphs, see if things correlate, and like we hypothesize, we figure out if the hypothesis is correct or not, we create more graphs, and then the visual pattern is really what tells us what went wrong. And so the experiment looks like this. It's kind of like a tool that can be used by both an engineer and an AI for exploring time series data. Through this experiment, what I wanted to do is figure out 3 ways to work with time series data for AI. So the dumb way is just to give it the raw data, just give it a bunch of values, just all the time series data, comma separated, JSONs, things like that, and see if it figures it out. Better way is to use summary statistics. So some sort of statistics library will perform analytics on the data, give you some minimums, maximums, whether there's any correlated changes, whether there's anomalies, and then give that to the AI as an input. And then the third way, which is the most interesting to me, is using screenshots as like the actual basis for giving the AI just a way to look at the chart visually. And so this UI that I created essentially has all of those modalities, and I'm going to do a demo in a bit. And the hypothesis is that vision would be a good modality for that. And this actually is backed by some research, and somebody actually made a benchmark for how well LLM or VLMs understand charts. What they figured is that essentially they're pretty good at it. Sometimes they fail when there's a point outlier, and yeah, you can look into the research, but in general, they're pretty good at understanding a chart visually. So the architecture of this is mostly tool calling, and we'll see at the end like the insight from this. But pretty much every function in this tool is kind of a LLM tool. Some of it is client-side tools, some of it is server-side tools, and they kind of complement each other to create the experience. The process is an engineer goes and says, hey, this device is overheating, something is happening. The LLM goes and uses its tools to figure it out. And I'm going to go to the demo now. Cool. So this is what the interface looks like. Essentially, it is similar to what you would see in a normal graphing tool. So you have your devices, your signals, you can create charts. The difference is the AI can also do that. So you can ask it to list the devices. It will be able to figure it out from the context that it has all of these 4 devices. You can ask it what, kind of hard to do with one hand, but sorry, thank you. So what metrics do we have? And it figured out that we have like temperature, humidity, and so on. And the cool part is you can ask it to, can you plot the temperature of device 3? And then it will go and use a tool, a client-side tool, to create the chart. Now this is not faster than you just clicking the chart. So a better way to use this is to actually give it a task and have it use its tools to figure it out. So you can do things like plot all temperature charts from all devices. And that's slightly faster than what you would do by hand. And then the exploration part is that you can actually ask it things about the chart. So do you see anything wrong with the temperature of device 4? And here I have all the modalities enabled, so it has the chart summaries, the raw data, and the visual, and we'll see what it uses, but it has access to all of them. And so here it shows to use the screenshot, so it actually is capturing a screenshot, uploading it to an LLM, and the other LLM got asked to identify the anomalies, and it figured it out. So yeah, that's kind of the demo. Is it's a playground that you can use to play with what's better. Is it the summaries, giving the raw data, or actually using the screenshots? Thank you. So back to the presentation, I think like some of the learnings here is that building AI agents became less about coding and engineering and more about management. So you can think of it as, what tools do I as an engineer need to provide this agent for it to be able to perform its job effectively? And it's kind of like a paradigm shift in engineering where essentially the better the tools you provide to the AI agent, the better the data is, the better their job, the agent is going to be. Yeah, so this is like the stack, some prior art if you want to look at it, and that's the end of my talk. I'll take Q&As.